everyone. So today we've got a math question involving vectors. So we're finding the angle between the vectors u 4i minus 5j and the vector v 11i minus 12j. Find the area of the parallelogram formed by u and v. So this question kind of ranges across subjects. Sometimes we'll see it in trigonometry, in pre-calculus, and then for sure you see it in linear algebra or in calculus 3. So if you're given two vectors, u1i and u2j, and v, which is made up of v1i and v2j, the cosine of the angle between them is equal to the cosine of theta is equal to the dot product between u and v. That's what the circle in the middle between vector u and vector v means in that formula that I have around with the blue rectangle, divided by the magnitude of u over the magnitude of v. This works not just for vectors in two components in R2, it can work in R3, R4, in fact, pretty much anything here. That formula is valid. Now, what does u dot v mean? It's the dot product means that it's an operation, and we're going to multiply the components of each of the corresponding components of the vector. So the first component's multiplied, and then the second component's multiplied, and then we sum them all together. So u1 v1 plus u2 v2 equals u dot v. And the magnitude of u is equal to the square root of u1 squared plus u2 squared. So you square each of the components and then take their add them and then take their square root. The magnitude of v equals v1 squared plus v2 squared, square root of all that. So let's apply that to here. I'm going to write out what u dot v is, magnitude of u and magnitude of v, and then plug that into our formula. So it's going to be, for the dot product, you're going to take the I components and multiply them. Then you're going to take the j components and multiply them. So the I components were negative 4 and 11, multiply them. And the j components were negative 5, negative 12, multiply those together. And you get a negative 44 plus 60, which comes out to be 16. Okay, so we'll circle that number, just there for reference. The magnitude of u now would equal minus 4 squared plus minus 5 squared. So it's equal to the square root of 41. The magnitude of v is going to equal 11 squared plus minus 12 squared. So it's 121 plus 144, which is the square root of 265. And applying our formula, you're going to have the cosine of the angle theta between them is equal to u dot v, which is the 16, divided by the square root of 41, divided by the square root of 265. And the angle theta between them is cosine inverse 16 square root of 41 square root of 265. Now when we asked for the angle between two vectors, draw like this little generic picture, and let's say that's u and v is here in green. Technically speaking, there's two angles. There's one is usually larger than the other, except that the angle between them is 180 degrees. Yeah, we're always looking for the smaller angle between them, okay? And this, look, when you take the cosine inverse, that's well defined, because cosine inverse gives you something between 0 and 180, inclusive of 0 and 180. So it's not going to give you something bigger than 180. So that's why that formula is well defined and works out pretty well for us. So you get some angle out of this. If you want to approximate it, this is the exact answer. If you want to approximate it, by all means, you can put this into a calculator. Now, for the second part of the question was to find the area of the parallelogram. And the idea with that is, yeah, you have the two vectors, u and v. You put them together, and you have this parallelogram by joining the tails and the heads of the other sides together. And basically the area of a parallelogram is equal to the magnitude of the cross product of the two vectors. That's one way to look at it. Or you could also use this other formula, which is the magnitude of u times the magnitude of v times the sine of theta. I'd rather use the second formula here, because I actually know what the cosine of theta is, and I can find what the sine of theta is. And technically the cross product is only valid for 3 components. You have to be working with a k component, right? The z, sometimes we call it that. And we don't have that here, but it actually applies. But anyways, we're gonna go ahead and work with the second formula. So the sine of theta is really what's missing. We know what the magnitude of u and the magnitude of v are. We have that cosine squared equals, or cosine squared, excuse me, plus sine squared equals 1. In other words, sine squared equals 1 minus cosine squared theta. And if you were to plug in cosine from what I had a second ago, that was 16 over root 41 over 265. You're going to go ahead and square that out, and this is going to be equal 1 minus 256 over 41 times 265. And you would calculate this to get, some number out of this whole thing. Yes, you're going to have to use your calculator. And that actually comes out to be 10,609 divided by 41 over 265. And the sine of that angle will be the square root of that number. Okay. 265. Or I can break this up as 10609, square root of that, over the square root of 41 over the square root of 265, sine of theta. So finally, for your answer, for your area, the magnitude of u times the magnitude of v times the sine of theta, this equals the magnitude of u, which is the square root of 41, times the square root of 265, times the square root of 10609, divided by the square root of 41 times the square root of 265, and these would cancel out nicely, and there you go, and that's your area. Okay, so if you did the cross product, you'd get the same thing. But yeah, it's a nice, if you have the angle between the cosine and the angle, that's a nice thing to use. All right, thank you for your time. Hope this helps.